Hey, it's Mr. Lum again, and we're going to be continuing our talks on electrochemistry, and on this lesson we're going to be just doing a little bit of vocabulary. So, last time we looked on how we can make electrochemical cell. We looked at how this particular electrochemical cell works. We saw that Zn, or zinc, right here was losing some electrons, and electrons were going through this wire, and they were going down to the cathode here of Pb, and that makes Zn the anode, and that Zn right here was losing mass because Zn solid, or zinc solid, was turning into zinc ions. Okay, and the ions that were here in Pb 2+ were turning into Pb, or lead solid. Okay, and it was leaving behind NO3. NO3 minus. Now, which made this solution quite negative since there's so much NO3, and this solution became quite positive, making Zn2+. This solution negative, this one positive, they're attracted to each other, and so the zinc 2+ would move up into the salt bridge, and because it's attracted to this negative solution, and NO3 would move into this salt bridge as well because it's attracted to that salt bridge as well. Okay, and that was the basic structure of the electrochemical cell right here. So again, electrons traveling through the wire makes volts, or electricity. Now, what are volts, or voltage? Well, it's volts are the work done per electron. So it is not the amount of electrons that go through, it is how much work each electron can do that travels through this wire. Okay, so the amount of electrons that are traveling through there, that's something different. That is current. You can ask your physics 12 teacher about that kind of stuff. But the amount of work each electron can do is the volt. Is measured in volts, sorry. And how we do this is we have to have a difference in reduction potentials. So we look at a reduction potential table, like this one right I have here, and we can measure and see what are the differences in these reduction potentials. And for this particular one, we saw that this one, Pb right here, was a better, that this Pb2+ was a better oxidizing agent, and Zn was a better reducing agent. This lost electrons much better than everything else here, and Pb2+ gained electrons much better, and that's why we see Zn is losing electrons and Pb is gaining electrons. And so our reduction potential from the reduction potential table is the tendency of a half cell to be reduced, and all of these numbers here are measured in volts. Now, the numbers that you see on this table, I know it's really small, but you have to look at your own table. All these numbers here that are measured in volts are not the absolute potentials. It is not the number, it is not the actual number of volts that it produces, but instead it is the difference, the difference in these reduction potentials, and it is the difference that we get our volts. So everything, all these numbers right here are compared to something. And if you look on this table, you'll see that it's all compared to this. 2H plus 2 electrons makes H2 gas. Now it says the volts for this one is 0.00. Now it does not mean that this produces 0.00. It means that everything is compared to this. This is the standard that everything else is compared to. So this compared to, say, the very top one right here, 2.87, that means the difference between those two is 2.87. That means the potential that you can get a volt through here is 2.87. But if you had something right through here, the difference is much, much smaller. And it's the difference that we're looking at, well, that we will be looking at in future videos. Okay, so we want to be looking at the difference. So this thing is all about comparing. And it's everything is compared to this one right here. Now, on this table, everything is measured at standard state. Now, what is standard state? Well, if you look at your table, it'll say here the ionic concentrations are 1 molar and in water at 25 degrees Celsius. 1.0 molar, 25 degrees Celsius. And for things like this that have gases, the pressure of these gases are always at 101.3 kilopascals. This is standard state. If you change this to 2.0 molar, or you change the temperature, or you change the pressure, right, these numbers cannot be used. These numbers will change. The reduction potentials will change if you change the state that it's in. And we'll talk a little bit more about how these reduction potentials are going to change and what can that do to our electrochemical cell. Okay, that'll be next time. Today we'll just talk about a little bit of vocabulary and a little bit of review.